So let's start with question one. It's a distillate total condenser partially boiler problem. You start by finding R min. You need the quality for that to get the slope. Basically, quality was 0.5 because it says half vapor, half liquid. And then I got this one to be M equals -1. Connect the lines from XD to the intersection point of the feed line because this slope gives you the feed line. And then from that, you find R min using the handout we're given for the equation, and R min equals that, and then you times it by the relationship that gives you 2.8, and then you plot your top operating line, you get an intersection point, and then your intersection point, you put that to your XP, that's your bottom operating line. And then because it's a partial boil, it's 100% efficient, so you go all the way up, and then it's a 75% efficient all the way up on the other trays. So partial boil is 100% efficient, all the other ones are 75% efficient, and then you follow it up until you pass the intersection. Then you do the top operating line, so the bottom operating line, as you see here, and then the XB, you go all the way to the XB. Stage one, total condenser is not included in here because it is a total condenser in the tray, so it's 5 trays plus a partial boiler. If it was included, it'd be 4 trays, a partial boiler, and a total condenser. But because it's a total condenser, it's not included in your trays. And so yeah, I got 5 trays. And then for the next one, I did a mass balance around the um, like the total condenser, like the total condenser, and the whole thing. So like F equals BD, F equals B plus D, and the component of that to get B and D, and then I use the definition of like reflux is L over D, and then I got um, and then I got B equals L plus D because the vapor is this line, um, and then this is D and that's L. So like the vapor, it has to be L plus D, and then I got the vapor to finally be 193.8551. For question two, it was a lot of mass balances. I started around tank 2 to get I had to get a relationship of LF, which VF is given to us. Um, and so I found LF first via the relationship of V over F. And then once I did that, I did a component balance to get Z2, which is equal to X1, like you can see in here. And then once you find X1, you can look at the equilibrium thing, and then you find X1 here, you go up, and then you hit the equilibrium line, and you have the temperature right here of the drum, so 78, 78. You look across from it, and you should get the mole fraction of methanol. And then you kind of do the same thing for the next one. You have to get the X1, which was um, not given to you, but X1, which is X2, and that's how I got that. But for the tank 2, X2 was given to you here. It's 15, so you look here, and you go up to 84.4, and then you do like a bunch of component and mole balances to find everything else. So like the V's, the L2s, like this row, you find V mole balances that you can just go around and do component and total, because it's 2 unknowns, 2 equations, and then the other one you use the equilibrium. So you just need to find either your Y or X, and then you look up to get it, if that makes sense. And then the third one, I used an enthalpy equation of the feed line, because the feed, it's adiabatic, so Q is 0, and the feed should equal LHL plus VHV. And so I started doing it that way, and then I realized that to get the temperature, I just needed to get the feed, like the enthalpy of the feed, based on the diagram here. Because it's a 300 liquid, that's really, really hot, but it's at high pressure, so you can see it's a liquid coming in. And then you can use the 1 kilogram center because this is exactly what the diagram is asking. Um, and they're looking for the T drum, and you can find the T drum using the enthalpy of the feed via the HF here because it should equal the LHL and HV. And so the enthalpy of the feed, it's like all liquid because you want a liquid to be in a flash and not a two-phase or a vapor. And I used this equation because it's the CPL and the TREF, and I didn't want to deal with the units, so I divided it by molecular weight to match like the units here to get HF, looked at HF on this side and looked across, and then you have the concentration of ethanol like originally given to you as 35, so you go here and that's 91 degrees Celsius. Thank you, and have a nice day if I can stop recording.